So I'm here today to talk to you about dependency testing. But before I get into that, I'm going to talk about myself a little bit. I've been involved in software quality in one way or another for more than a decade now. And no matter where I end up or what I end up doing, I end up usually doing two things. One is automating either tests that improve software quality or automating things that improve software at delivery time. And in both those exercises, I run into this continuing problem of things that my team doesn't control affecting the quality of our software. So over the years, I've thought about this problem a lot and what the best way to solve it is, and thus dependency testing. And now I'm going to stop and thank you all for being here because this conference only works with people coming and engaging with ideas. So I'm happy to share my ideas with you. And I look forward to hearing all your lovely questions. And one other thing I want to get out of the way is there was a little bit of miscommunication on my side. And I thought that I had a 30-minute time block that I had to allow 10 minutes for questions and answers for. And as you can see, we have a 40-minute time block. So we're going to wrap up a little early and you guys can all get something to eat before the uh, lunch session. So that's good news for everybody here, I think. So what is dependency testing? Well, dependency testing is a testing activity. It's not necessarily a type of testing. It's any test that validates your application or your code's dependencies. And a dependency is anything your code relies on. It's in the name. So these can be environmental, such as your cloud environment, or maybe even a physical server environment, or a VPN, or anything that your code needs to run physically on. It can be functional in the case of a third-party library that you've integrated into your application, or it can be performative, which similar to the environment, but could also be code as much as it can be hardware, because you never know exactly where performance bottlenecks start occurring. Now, as I said, dependency tests are not a type of test. And I really want to talk about that for a moment because a lot of you are thinking, this sounds like integration testing. This sounds like unit testing. This sounds like API testing or some other form of testing. And you're not wrong. You're correct. I'm going to be talking about a lot of types of testing. But what's different with dependency testing is we're not testing the code that's controlled by your team or even necessarily by your company. We're testing code developed by others that your code relies on. And that's really the big sticking point. And that's also the hard sell when you go to your manager and say, I want to increase our code quality by testing somebody else's product. And if you bear with me, I'll explain how this can benefit you and how this can make debugging problems that occur suddenly without any warning considerably easier. So let's start with some background. Modern software is very complex. With the rise of massive cloud service providers, software has become entangled in numerous sub-applications. What used to be synchronous communications has now become entirely asynchronous to the point where your application may be doing 30 different things at a time and not waiting for any actual responses. It just retrieves and sends data as it needs it. At the same time, we're breaking down traditional monolithic software into microservices, which leaves a whole bunch of little interconnected modules that may be hosted locally, they may be hosted in the cloud. You might not even know some exist because an application you relied on was broken into 3 different applications that all rely on each other, but you, from your standpoint, still think of them as one entry point into another system. And as I mentioned, at the beginning, we're highly reliant on web services. And because of this, it's almost impossible to map out your application's interactions and your application's use cases. And that's a big deal when we're talking about testing dependencies, because applications and use cases and functionality is very important. And understanding that is the first step on our journey. The good news, though, is the whole journey is only 4 steps long. This is going to be a very practical presentation. I'm not gonna focus on sort of higher ideas. I'm going to get right into it. Dependency testing is achieved through four relatively simple to understand steps, but they are complicated to implement, and sometimes there will be steps that can't be completed for every dependency, and that's okay. Anytime you're testing something you weren't testing before is better than not testing anything at all. So what are our four simple steps? Well, number one, you need to figure out what our application is dependent on. What are the things we need to work? What are the things our customers need to work? And what are the things that if they fail, we need to fail in a specific way so that we can understand and mitigate those failures? That in itself is a huge undertaking that we'll get into in a minute, but it's also the foundational step to dependency testing. Understanding what your dependencies are and how your application uses them is absolutely key. The next step is application refactoring. This is another difficult step because while your application may use a number of dependencies, possibly numerous dependencies, possibly dependencies you don't even know about, none of what we're going to talk about today makes sense if your application uses the dependencies in ways that aren't testable or ways that can't be understood. So once we know what the dependencies are, we may need to take a look at the application and how the application interacts with the dependencies and change that. And we'll talk about application design patterns and a couple other techniques to do that later on. But that is an important step, that in testing your dependencies, your application may need to change how it uses the dependencies in order to make higher quality tests that return more actionable results. Because really that's what we want here, is actionable test results from our dependency tests. Otherwise, we're just testing somebody else's software for free. So finally, we'll move on to test implementation. This is the step that I suspect most people here are familiar with, as this is a software quality conference. I don't think I need to go over how to write test plans and how to execute on them, but that is the third step in this process once we understand the steps beforehand. And then finally, we're going to talk about how our tests can be executed and what their results mean to us and what we can do now that we have these tests. Because there's a couple of things that are perhaps not obvious, and I'm really excited to share those. So, like I said, the first step is cataloging your dependencies. The obvious place to start understanding what your application is dependent on is looking at any application documentation. Now, if you're like me, you've worked at a number of places and documentation varies wildly in quality and quantity. So we can't just stop here. But this is a great place to perhaps find things like, what are the big dependencies? Because those are almost always written down and always referenced multiple times in documentation. Example, are you using AWS or are you using Azure? That's a really big dependency. It's usually very easy to figure out from nearly anything written down about your application. And even if the application's outdated, there's a good chance your company is not hopping web service provider over and over again. Other documented dependencies will probably be other internal projects to your company. These tend to be written down well because people and teams like negotiating how their various parts will interact. You might miss third-party libraries that people pull in through package managers such as NuGet in the documentation, and that's where you're going to need to move on to the code base and actually look at when my code builds, what is it pulling in? What are the packages that are dynamically linked? What are the packages that are statically linked? What are the things my application uses in the code base? This is actually remarkably easy to find because in most and all programming languages I can think of, the packages your code uses are listed at the top of any file that the code is written in. And so you can start there. If that's all you have, it's still written down somewhere. And that's usually version controlled. So you can see when things were added if you really need to, which is a huge help and I think overlooked. And then finally, your build and deployment system. As CI/CD has evolved, the complexity in which software is deployed has evolved. In your test and staging environments, your build system may be injecting testing versions of various dependencies, things with more logging, more debuggability. Maybe they're single threaded as opposed to multi-threaded. So that way, should a crash occur, they can be diagnosed easier. But that's not important for dependency testing. We need to know in production what versions of these packages are being used. So if you're utilizing dependency injection, it's very important to know what version of your dependencies is injected where in your pipeline. And then you have to make the call, do you want to test that twice? Do you want two sets of a test to be sure that it continues to run in your production environment, which is what we really care about for this exercise? And how much do we want to dedicate to testing test packages? Once you have all of this dependency questions answered and cataloged, and you have a good idea of where your dependencies are, how they're used, what gets injected when, this is the important time to make an actual catalog. Write down everything if you can, all your dependencies by name, and ideally how they're retrieved, and then how they're retrieved or how they're interacted with, I should say. And then how changes get made to them. Example, there's a good chance you won't make changes to your web hosting environment without proof of concepts and other things. But a change to a package might be as simple as somebody notices that there's a new version of that package and wants to integrate it in. So it's important to know not only what your dependencies are, how they're used, but how they change, because how they change will affect the fourth step of the process, which is how we trigger our tests. Now that we have all of our dependencies written down, we need to talk about how they're used. And this is where things get really tricky, because good dependency integration is directly proportional to good dependency testing. And this is where I said earlier, a lot of this is going to sound like other forms of testing. And that's because, like I said, it is. Right now, we're mostly talking about integration testing. How does this code interact with our code? In design pattern terms, we want to ask some questions like, does the dependency have a service layer? And is that service layer sort of confined to discrete classes or packages in ways that are either portable, ideally portable, in fact, or is that statically linked into our code? And then perhaps most importantly is, can this dependency, if it requires configuration, be altered without needing a code change? Either is it driven by environmental variables or configuration files or things within our pipelines and production environments that allow it to change its behavior? And you really want to be able to answer yes to all of these questions. We want our code dependencies to have service layers. We want them to be confined to discrete classes or packages, and we want to be able to configure them without changing any code. And the big reason for that is ultimately any tests we have, especially if we're automating, we want them to be able to use the exact methods of interacting with the dependency as our production application code does. This way, we're starting to double up on tests. And I'll talk about that in the next step where we talk about actual test implementation. But it is really important that if we're writing tests, the tests need to behave the way the application does when interacting with the dependency. And the best way for us to know how to do that is if our code is written in a way where it's easy to understand how we interact with the dependency. So that's where, for step 2, we should take some time, look over how our dependencies are used, and make any upgrades or simplify any code or separate out functions as we need, because without that, implementing the tests will become a big pain and we'll end up with fragile tests, and fragile tests get turned off. So now we're here, we're ready to talk about test implementation. So as I mentioned, we're going to be talking about a lot of different types of tests. The first step is determining the appropriate approaches. Almost all dependencies need some form of integration, performance, and functional test. This could be an API, this could be a package, this could be a web service layer. It doesn't really matter. You need to know that A, your code works with it, B, it works to the degree you need it to, and then C, the functions are accurate to an acceptable degree. In most cases, that's all the time. All the time you need all the functions to work the way you expect them to. So once we sort of decide and look at various approaches, we start building out a test plan based off of these requirements. How do we use it? What does it need to, how often, how does it need to perform? And then how does it need to execute? We can start mapping test cases by type directly to our use cases of the dependency. And this is another really important bit for dependency testing. We're not testing this third-party code for fun. We're not doing it for the other company or the other team. We're doing it for us, which means all the tests we write need to map to a use case that we actually have, not something we want or not something that they promise. I work in companies where dependencies are adopted into the code base, usually third-party libraries when this particular event happens, where over time that library has changed and maybe some features have become deprecated. And then obviously stories are added to the backlog to sort of redo how we interact with that dependency. But in the meantime, it's important that our test case still maps to that deprecated feature because that's what we use. We're not testing the new way to do it. We're testing how it works. So that way, should it break, we know as soon as possible. And this gets one step trickier because you might find yourself writing a test case that is now specifically for functionality that is not supported, may never have been supported, but it is, for one reason or another, how your application interacts with the dependency, which makes it not only an important test case because that's how the dependency is used, but a vital one because you know that that's not how the dependency is supposed to be used. And you really need to know, should this unsupported functionality you're relying on breaks. Once we've sort of built our test plan and decided our approaches and looked at our behavior and use cases, the next step is to properly tag your test cases. Most test management systems allow for tagging of some kind or another. I can't think of any that don't at least have some basic form of tagging. And this is really important because you'll want your integration and functional and performance tests and your API tests to all run at appropriate times with the rest of your larger test suites. You don't want to be constantly hounding your dependency with performance tests when the rest of your teams aren't ready for these performance tests. So it's not a good idea to lump all your dependency tests together under the folder dependency tests and sort of just run them. They should all be marked as dependency tests. So if you wanted to run them all, you can. But since there are so many different types of tests in there, some of them do have specific considerations for running since they might cause disruptions. And you'll want to be able to control when they run. So we have our dependencies cataloged. We've examined our code to see how these dependencies are used. And then we've actually written our test plans and organized our tests. We need to talk about when they run. The coolest thing about dependency tests is they're not just useful for development. Since we're talking about dependencies, and now I'm going to sort of break dependencies into two categories, internal and external dependencies. So an internal dependency is a dependency that's in your application. It's a third-party library that you've integrated in. It's that's actually really the big one. And external are things like external APIs and services. And the reason that this categorization is important is generally we can control when a third-party package gets upgraded. That gets pulled in, usually as part of a sprint item. Sometimes it's done on the fly, hopefully not, but this type of testing will protect us from that. As opposed to APIs, which live out in the cloud for the most part, and you can't control when they update or who updates them or what functionality is deprecated in most cases. And that's where it's important to talk about when these tests trigger. So if they're organized correctly, you can trigger them based off of the dependency itself, just whenever you want to. If it's, say, a dependency test for a package, you can trigger that off of changes to your code base, or if you want to be slightly more microscopic, changes to either the package or the integration classes for that package. And then performance triggers are a fun type of trigger where, since this is all our code, and we understand how it works, how it interacts with the dependency, we can add things like log messages to trigger our tests. For example, let's say we have an API dependency. Something out in the cloud. Let's just say for the sake of it, it's, our NTP server. I don't know why. Anyways, our application reaches out to check the time, and it's given back a 500 or a 404 or some bad message that an NTP server probably shouldn't be giving out. Now, maybe that's okay for the first time. We can miss a couple of call-ins, but after our application has logged, say, 3 times that it can't hit this NTP server that it likes, maybe we run the performance tests. Maybe we see if it's up. Maybe we see if it can handle any requests right now. And that result is those tests are now running in real time in sort of a production environment, but not necessarily against your application. But they allow whoever's plate this problem is going to end up in front of to start debugging from a place of knowledge, a place where they know we're having an NTP outage. Here's the tests for that NTP server that ran, and we know that we can ping it, so the server's up, but we can't actually access anything. So that really means that the service is down, even though the server is up, and that helps them solve the problem faster. And that's the big takeaway, really. Dependency tests are about solving problems with your dependencies faster. But before I dwell on that, I want to go through an example. I want to sort of walk us through with a fictional application all of these steps and see where we end up. So I have in my head constructed a navigation application. It is not one that is going to soar to the top of the app stores anytime soon, but it works for this example, which is to say you plug in 2 addresses and it gives you a route between them, but it has the feature of users can report collisions or traffic flow disruptions that the application will then route them around. So that's it. I'm not even necessarily thinking of adding live location data to this, but we might, because who knows? Oops. So what are this hypothetical application's dependencies? Well, it's a mobile app because that's how we navigate, which means that there are a number of mobile devices, often in absolutely competing marketplaces, all of which are entirely unique. And everybody who's done mobile testing right now probably understands that pain. Number 2, we need a database because we need something to store, at the very least, a list of current collisions and traffic disruptions for given areas, because we want them organized in a way that we can query, because having just a list of every traffic disruption on the globe at one time would be impossible to search through and completely useless. And then we also need some form of map library, because we're not Google and we can't hire a whole bunch of people to drive around in their cars and actually map the planet for us. So we're going to have to use somebody else's. So now with those 3 dependencies, which we will have more of in a real application, but like I said, we're limiting it to 3 for the purposes of example, we need to be sure these are integrated properly. For the mobile device, we need to make sure that any calls our application makes that ultimately are dependent on, is it an Apple phone? Is it an Android phone? Is it a Windows phone? Whenever Windows launches another version of the Windows phone, we need to be sure that all those calls are isolated into a service layer. So that way, in a very object-oriented way, our application can decide what call is actually correct to interact with the phone hardware. This way, we can suspend the rest of our application and testing in a way that allows us to better emulate not only the devices, but then we also have these sort of integration classes that we can use to test on the specific phones. So next is the database. The database lives in the cloud, so we should probably make a client for it. There's no way every phone's going to have a copy of our database on it. That would be chaos. So we'll make a client for it, and we'll make it so this client is actually configured by a configuration file that is sort of auto-refreshed every time the phone makes a new route. So that way, if we wanted to, we could take a live deployment of this application, change the configuration file, and make a new route, and it would connect to a new database. And we do this because when we want to test our database, we want to use perhaps not our production database, for those dependency tests. So we have a separate test database stood up. And then finally, our map library. That is something that is going to be completely controlled by somebody else. And we'll want to be sure that all calls to it are similarly insulated. So that way we can use those calls to execute our performance and functionality tests anytime that map library is updated. So what are the tests for this? Well, number one, we probably want a simple set of tests that every time our phone OS on our supported devices updates, just checks things like, can we access the file system to reach our configuration files? Can we accurately, store information if we want to keep a trip history locally? Those sort of things. Can we display to the screen? Just very basic tests that run every time a new OS update goes out to the phone. So that way we can have complete confidence that everything is going to work on the phone side. For our database, these are actually going to resemble API tests. Is the database up? Can I write to it? Can I read from it? Can I query it? How fast do these queries return to me? And are they fast enough that they fit within my use cases thresholds? And then finally, the map library, which, since it's a third-party package, we can test every use case because we'll have an entire list of the use cases in our code base. And these will actually look more like unit tests than anything. We'll go through the integrating class and just wrap every function we can find in, let's say, 2 unit tests. One that actually sort of does a little bit of in-out functionality testing on everything, and a second one to see how fast that map library returns the information to us. If we need to hit for complex routes, we might be hitting it, however many turns or however many collisions. We need to know that we can build a route with 1,000 turns or 1,000, steps, I should say. So finally, we need to know when these dependency tests run. Well, I kind of gave it away a little bit with the mobile device. Every time it updates, every time the OS updates, we need to run the tests. Other than that, maybe every time they add a new product that we want to support, but the most part, those will be pretty regulated tests, barring any surprise security updates that might take us off guard. For the database, these can run anytime our code base changes. They can run anytime the database changes, or we can start adding those tests I sort of talked about earlier, where if our application logs back to our sort of home server, hey, I can't access the database. In this case, say we have 10,000 users. If 0.5% report a database outage, maybe we run the performance tests to see, are all the connections used up? What's going on with our database? Why can't we contact it? That sort of thing. Get a little bit of live feedback in a way that doesn't stress the application and hopefully doesn't stress our database as well. And for the map library, this is probably the easiest one to choose dependency triggers, testing triggers for whenever the library changes and whenever our code changes. And that's basically it. So I know I covered a lot relatively quickly, but there's a couple of just very key things. Your application, my application, everybody's application these days relies on uncontrollable systems. These systems can be updated without your team or my team or anybody's permission or sign off, especially in the case of cloud services, web APIs, or even things like DynamoDBs that are just hosted as part of your cloud service. Because of this, you want to be able to mitigate errors as quickly as possible. And the best way to do that for these third-party uncontrollable bits of software that your software is heavily dependent on is to understand how your software uses it and then make sure to test that. And I know I talked a lot about automation here, but nothing that I said today can't be applied to manual testing if that's where your team is at. If you understand how your application uses its dependencies, there's no reason those test cases can't be followed by a human being just as easily as they can by software, especially in the case of APIs. I know a lot of people think about ways to automate API tests, but there are tons of tools that can be used to manually test APIs, and there's really no reason not to sort of engage with the requirements your application has on its dependencies. Dependency testing is an activity. It's not a specific type of test. I've talked about many different types of tests. Dependency testing will most often look like integration testing or performance testing. And that's because those are probably the two most reliable and useful sort of test results you can get back from your dependency. But there's no reason that every test type can't be included. Big dependency testing actually before the fact is just fitness testing, where you're asking yourself if you want to include this package or library into your application. Those fitness tests that you come up with, they can be recycled later if they're actually representative of the use cases you use. And then finally, if you automate your dependency tests, you can use triggers to help you diagnose problems. And that's really the important part, is since we're talking about third-party software that gets updated without your permission, knowing when something goes wrong as soon as possible, but not only if, but what, is immeasurably valuable. So thank you all, and I hope you enjoy the rest of the conference, and I will now be taking questions.
Thank you, Eric. It was a terrific presentation, very applicable, very useful, very practical. I like this type of presentation that I can take and go home and do some stuff with that. So just a reminder to everyone to that we have survey where you can fill feedback about presentation and the conference. So please do this. And let's switch to the questions. It looks like I have problems with my audio. Is it better?
Can you try saying something again?
Same.
Oh, no, it's still pretty staticky. Okay, well, I'm not seeing any questions, so thank you guys all very much for attending. And Irina dropped the survey link, and please fill that out if you can. Oh wait, I got a question. Okay, how do you handle major upgrades by the other system? Well, so that's kind of one of the major points, and I guess there's a number of ways you can handle that. If you're lucky enough to know that it's going to happen, you can prepare a specific test plan ahead of time, especially if you have, say, things like release notes. If it's a surprise upgrade, then hopefully your understanding of how your application interacts with that system is sufficient for you to put together a test plan. And that's where step 2 is really important, the refactoring of your application, where it's crucial to understand how your code interacts with another system. So that way, when you write a test plan, it represents the use cases your application is reliant on. And maybe that's the question in one sentence, is focus on the actual use cases your application uses, and don't just think about how you would test the third-party application, because that's the pitfall. Okay, we have another question, which is, where in the automation development cycle do you recommend this built, i.e. after regression test is complete, once you have a basic acceptance test, etc.? I honestly struggle with this one. Part of me is instinctually wanting to say as early as possible, like sometime in the design phase, start to determine, hey, how are we using this dependency? Realistically, I would put it later. I would put it after acceptance tests, because once the acceptance tests are done, you know that your application works how your customer wants it. which means however you're using your dependencies are how you want to use them to get that positive result. So I would put it after acceptance testing.